Anybody that has started in electronics a bit ago knows Radio Shack. They always had cheap testing components and just items that were kind of cool for their time. So I thought it would be really cool to do a video. I still have some vintage Radio Shack components. Remember the Micranta brand and just Radio Shack brand, and I believe there was some other ones too. So I have some test equipment and even a soldering iron. And I thought, well, do they work? And also, do they work with today's electronics? And so I thought it would be really cool to just check them out and see if they're still any good and how they compare to some of the newer stuff. So let's get started. Okay, the first item that I'm going to get started with is this digital logic probe. And if you look at it, it has a high, a low, and a pulse. And you can set it to normal or pulse, CMOS or TTL LS. So definitely when it was came out in its time, it was pretty cool. And I guess you would use an oscilloscope for the most part today. So let's give this a shot. I have a microprocessor-based board here. This has, I'm not sure which microprocessor, but we're going to get started and see how this works. So I'm going to set it initially at normal, and then I'm going to set it at TTL LS, and we're going to see how it works. So I'm going to actually turn on my bench power supply. This board takes 12 volts, and I'm going to feed it 12 volts. And let's see, for example, I'm going to put this on, well, the 5-volt line. So that's going to be positive, right? And as you can see, that red LED comes on. And it says high. So that's a high level. And if I put it on a ground, which would be this one, the green LED comes on. I think you could see that there. And it has like a lower beep. So that's kind of cool. Let's test out this switch that's going into this microprocessor here. So let's give this a shot. Looks like this is high. And when I press the switch, it's probably brought up the high. And then when I press the switch, it brings it down to low. So it's probably held high by a resistor. And then low. So you see high and then low. So that's pretty cool, right? But what does the pulse do? So let's put it on pulse and see what that does. So we're actually going to put this on a crystal oscillator here. Any of these oscillators. And let's see if it detects the pulse, since it's oscillating at a pretty high frequency, somewhere in a megahertz. So I'll put it on the one lead of the crystal oscillator. And at this point, it shows both high and low, and all the lights light up and pulse. So you can see it might be hard to see in this light condition, but you can hear kind of the pulse. And high and low. And I guess with the pulse, it still does. Yeah, it still does a high and low, so you can still see it, but doesn't really make a sound. So that's really cool. It still does work. And I suppose it's still pretty useful, especially if you wanted to see, for example, if the crystal oscillator is good or bad. And you didn't have an oscilloscope, so that would be a good indication, as well as, monitoring logic conditions. So that's pretty cool. This little Radio Shack digital logic probe still works, and still's pretty good in modern day circuits. Let's move over to the next item. The next item, believe it or not, I use a lot, because by far it's not outdated in audio stuff. This is a transistorized signal tracer. So really all it's doing is it's a little amplifier. So let's say you wanted to see if a radio was good or not, and you're checking the audio signals, you could follow them through with this. So there's a common here, a volume. There's a speaker here. And there's the AF, which is audio frequencies, and RF. So you could follow an RF line too. If I'm supposing it would be for amplitude modulation on the RF line. And I don't typically use RF, but if I'm going to use the amp and all, I will use the AF and the common there. And so let's give it a shot. All right, so to test this, I'm going to bring out this Thinistry, or I don't know how you pronounce this, but this is kind of a little bit of a inexpensive oscilloscope / multimeter and signal generator. I'm going to use the signal generator part of it. So I am going to go here, and this actually tests components. So yeah, we've come a long way with a lot of this stuff. But some of the old stuff has its own elegance, and so I'm going to go to signal source on this. And as you can see, I'm just going to put a sine wave at 1 kilohertz. So let's see if this works. I'll turn it on. So I'm just generating an audio signal, and it works. So simple, and it still works to this day, and I still use it a lot. So I'd say that's definitely a win on that one. All right, up for the next Radio Shack item. Does it work, and is it any good? And this is going to be a component tester. So we'll move this item aside for a second. And let's get the component tester. All right, this is a component tester. And this probably was relatively new. I'll try to bring it as close as I can to this camera. And basically, this is kind of like some of the newer stuff, the LCD stuff that you can go in and you can test a transistor, SCR, and different components. And so this is like the early version of one of those things. And it was probably at the end of, before Radio Shack went out of business. So this was a later item that Radio Shack had. And it basically it has buttons, one for transistor, one for diode, SCR, and one for continuity. So let's give this a try. And if you look also, it has just basically, you can put a diode across that and it will identify the anode and cathode. And you can put a transistor in here and it'll show the base. And I believe the emitter on this one. So let's give it a shot and let's see what it does. So what I'm going to do here is let's do the first one, right? And it's a continuity check. And I believe it's between the black and the red. So if we hit that, nothing. But if we end up doing continuity, it ends up finding that continuity. Let's give a shot with a diode and a transistor. So let's try with this transistor. I'll plug it in here. And I just want to make sure you can see. It's a little hard to see here. But I'm going to plug it in. So it's plugged in those holes, just like some of the modern ones. And I'm going to hit transistor. And you can see that the base is the one that's blinking, I believe, on this one. I do have instructions for it. The base is the one that's blinking. This one that stays steady, I believe, is the collector. And I could be wrong on that, but basically it identifies that. Again, I didn't review the instructions. So some of the modern day stuff is nice because it just shows you what it is. But basically, and if it's bad, this light will light up, the bad light. And I'm not sure if you can see it in the light conditions. It's not easy to read, but it says bad, this particular one. So if I hit that, it's not bad. Now let's say I took the transistor out, right? It's going to show that it's bad. Another neat thing this did for its day it would show what kind of transistor it is. So if you look at this, this is an NPN transistor. So yeah, it was the early beginning of some of those modern day component testers. And let's give it a shot with a diode. Here's a diode. Let's just hit the diode without no diode. And you notice it comes up bad because, well, if a diode was open, it would be bad. So I'm going to put it in these holes here. Put that diode in. Hit it. If you notice, the stripe is over this side. So that's going to be the negative. So when we hit this, it's going to show that the diode's good because that is not lit. And this one lights up and it says that's the anode on this side. So that's an early day component tester from Radio Shack. So that was pretty cool. And you know what? It's still pretty good today. It's definitely not suited at all for in circuit testing because one of the reasons is it puts up the 4.5 volts. Okay, so here's a modern day version of the component tester. And the way this works is I will bring it back up here. And it just, you seat the component in these, the ZIF socket. Once it's in, you lock it in, hit auto. And you're going to see that it's analyzing and it will actually show the schematic. And it's kind of hard to see some of the stuff in the light conditions. Just try to shade it a little bit. So you can see right there. Shows which lead is it says here 1 is the collector, 2 is the base, 3 is the emitter. So it's really nice, some of the modern day stuff, but the old stuff worked well too. Just thought I would compare the two. And the next component we'll test is a continuity tester. Here you go, the wonderful Micronta name. You know what? And then you got it's called a latching continuity tester. And what's cool about this says normally open, normally closed, so you can test either of those. And there's a latch version and a momentary version and a reset button. So let's power it on. Let's hook it up to a switch. And let's see what it does. And you know what? What's kind of funny? You don't find this kind of tester today anywhere else. So this is kind of unique and no longer can you get something like this that I know of. Of course, you can just use a regular multimeter on continuity mode, and it's just like the momentary here. But this has a lot of neat options. So let's turn it on, and let's switch it to momentary. So when I hit the switch, you see the light lights up, and you'll see that it's on normally open. Makes a beep. Nice. And the same goes, let's say I do the normally closed. So when I actually hit this, does the opposite because that would be in a normally closed on it. So if the switch was normally closed and you activated it, but in this case, and what does the latch do? It's kind of neat. So if you switch it to latch and you're testing some kind of continuity that maybe is intermittent and you just want to look at it, and wait with it, and then all of a sudden, it goes into continuity. So that'd be good at testing something that might be intermittent. So when you hit the switch once, it just stays locked in until you hit the reset. And the opposite is also true. So let's say normally open is pressed down in this. The minute I would let it go and it go off, it would latch. So it's kind of cool. They really don't have something like this now. So it's kind of cool to still have something like this. And I haven't used it much, but it's good if maybe there's a switch that maybe opens with vibration or something. And again, none of these are for in-circuit testing. So that's just one thing you got to keep in mind. And a lot of testers aren't for in-circuit testing. And especially, definitely if the circuit's not powered, if it's powered, I mean, because unless you have just a multimeter, then it's a little different story. Here's an old Radio Shack. I guess this is a desoldering iron, and I'm touching it now because it's not plugged in yet. So as you can see, it's got like a bulb. And I guess this is a reservoir, and I guess you have to clean it out by opening this. And I definitely have used this, but probably not much. And I certainly haven't used it lately. So I'd like to see how well it actually does some of these components here on this board. So here's, for example, a through-hole capacitor. And if we look at this, a through-hole capacitor, and that capacitor, it will be on this side right here. So that's what we're going to do. And this flux marks, this was from the factory, believe it or not. I wouldn't leave a board like this. Not that it would hurt it, but it looks like crap. But let's just see if it actually releases that capacitor. I'm very curious. So that definitely is the capacitor. So I'm going to plug this in. We're going to wait, and I'm not going to hold you on the wait, but I'm going to give me about 5 minutes to get this thing heated up, and we'll see what happens. Okay, it's about 10 minutes, and let's see here. It's been about 10 minutes. As you can see, it has warmed up. So that's the first thing I don't like about this, is it takes forever to warm up. But it is a heck of a contraption. I'll put a little solder on the edges. And I'll also put a little solder on the edges here. And it looks like it's warm. I'm going to use some leaded solder. Always makes it easier to go and release these connections. And always a little bit more solder on the connections. Always makes it easier to release too. And I should be using my holders for this, but I'll go at an angle so you can probably maybe see it better. And so that's weird. Let's give this a shot. And that kind of, I guess, worked. Just need a... And I'll go here again. Heat that. And let's see if that capacitor is going to come out. And it really doesn't feel like it's going to come out, so I'll just use the wiggle method to get it out. So I'm not loving this. This is probably not as useful as it looks. Certainly a solder sucker or solder wick would do a better job, and looks like it makes a lot of smoke too. So I'd say that this vintage item probably is not all that great. So I don't think it's going to go back in the tool shelf. Anyway, that's it for vintage Radio Shack repair items. I hope you enjoyed the video. If you thought it was interesting, just like videos like this, like and subscribe. Thanks for watching.